You've probably heard people use AI and machine learning as if they're the exact same thing. And hey, you're not alone. It is one of the most common mix-ups in all of tech. But today, we're going to clear that all up for good. So let's just get right to it. AI, machine learning, are they basically the same thing? I mean, you hear them used interchangeably all the time, so it kind of feels like they should be. Well, not exactly. The relationship between them is actually a lot more interesting than that. So let's unravel this thing, and I promise, by the end of this, you'll see exactly how they fit together.
Okay, first things first. To get this right, we have to zoom all the way out and start with the big one, artificial intelligence.
Think of AI as the grand vision. It's this huge, overarching field dedicated to one massive goal, making machines smart. We're talking about building machines that can reason, learn, and solve problems, kind of like we do. It's the entire universe of intelligent machines. All right, so if AI is this giant universe, where in the world does machine learning come in? The easiest way to wrap your head around this is with a super simple analogy. Just picture AI as a giant umbrella. Now, under that big AI umbrella, you've got all these different approaches to creating intelligence. You've got robotics, right? That's about giving machines physical bodies. You have natural language processing, which helps them understand us when we talk. And then there's a huge piece of this puzzle, the one that's really driving things forward right now, and that's machine learning. See, it's a way to achieve AI, but it is not the whole story. So what's the big deal with machine learning? Well, it's a completely different approach. For decades, scientists tried to create AI by writing millions of if-then rules by hand. It was brittle. It didn't work very well. ML flipped that whole idea on its head. Instead of us programming the rules, we just give the machine a ton of data and let it figure out the rules for itself. And what's wild is, this isn't some brand new idea. Way back in 1959, an AI pioneer named Arthur Samuel defined it perfectly. This whole concept, letting computers learn on their own, that is the heart and soul of machine learning. Okay, so learning from data sounds cool and all, but what does that actually look like? How do they do it? Well, at its core, you can pretty much boil it down to 4 steps. It all starts with the raw material, data, and lots of it. Then you have to play detective and pull out the most important clues from that data. They call these features. Next comes the training, where the machine studies those clues to find patterns. And finally, you have to give it a test to see how well it actually learned. And that second step, picking the right features, is absolutely crucial. It's kind of like being a chef. You have to pick the right ingredients for your recipe. If you want a model to identify animals, you're not going to feed it data about their favorite songs, right? No, you'd give it useful features like has scales or number of legs. So once the model's trained up, how do we grade it? Well, the most obvious way is to just check its accuracy. What percentage of the time did it get the answer right? Seems simple enough. But hold on. What if I told you that a model with 99% accuracy could actually be completely useless? It's totally true. Imagine you're building a medical test for a rare disease that only affects 1% of the population. A lazy model could just predict healthy every single time. And hey, it would be 99% accurate, but it would fail at its single most important job, finding that 1% of people who are actually sick. This is why just looking at accuracy can be a huge trap. And getting a model trained just right is a real balancing act. It's like walking a tightrope. On one hand, the model can be too simple and miss the real pattern. That's called underfitting. On the other hand, it can get too smart and basically just memorize the training data, including all the random noise. That's overfitting. And the second it sees something new, it falls flat on its face.
Okay, so with all that complexity, where do we actually run into this stuff in our daily lives?
Honestly, it is literally everywhere. The movies Netflix thinks you'll love, that's machine learning. The spam filter that keeps your inbox from being a total nightmare, ML. That text you get from your bank asking if you really just bought $1,000 worth of tacos, that's ML too. It's the quiet engine running in the background of your life. Here's the perfect way to think about it. When you ask your smart speaker for your commute time, you're interacting with a big AI system. But the specific part that's crunching all that live traffic data to predict your arrival time, that's the machine learning model at work. The AI is the whole car, and ML is the powerful engine that makes it go.
All right, let's bring it all home. Let's put these two head-to-head in a final showdown to make it all crystal clear.
When you boil it all down, it really comes down to one key difference: scope. AI is shooting for the moon. It's this huge, ambitious goal of simulating human intelligence to solve all kinds of complex stuff. Machine learning is way more focused. It's a tool that's designed to do one specific task incredibly well by learning from data. So here's the most crucial point of all. While AI is the broader vision, machine learning has become the most common, the most powerful, and the most successful way we have right now to actually build those intelligent systems.
If you remember just one thing from all this, make it this. AI is the big goal we're trying to get to, and machine learning is the most important tool we have to get us there.
So now that you know the real difference, the real question is, what do we do with it? The potential is just massive. So I'll leave you with this. What's one problem, big or small, that you wish machine learning could just solve for you?